This video is on completing the square. Now, exactly what does completing the square mean? In short, it is used to transform an equation that has this sort of format, ax squared plus bx plus c, into something that has this sort of format, a times parentheses x plus d squared plus e. In both of these, x is a variable, a, b, c, d, and e are just numbers. So what would be the purpose, or what is useful about transforming an equation that has this sort of format into one that has this sort of format? Well, a few different things. One, in this sort of format, it is easier to factor the equation, easier to change this into parentheses times parentheses. It's also easier to solve in many cases. And in this format, you can determine the vertex of that particular equation. All right, now exactly how do you complete the square? Okay, so the general sort of steps on how to complete a square. First step you're going to do is prepare. And when I say prepare, I mean you are going to be changing the equation into a perfect square trinomial. And either there'll be a plus or a minus here, and then something else over here. This something else will be just a number. Next step, after you do that, you're going to change the perfect square trinomial from 3 terms. You're going to use the perfect square trinomial theorem in order to change these 3 terms into parentheses squared minus a number. Next, once you are done with that, the very final step, technically, after step number 2, after you have changed it into this, you will basically you will have done the completing the square part. But I'm going to have us go one step further than that, and I'm going to have us change it into have a step 3, where you're going to use the difference of squares in order to change you're going to use different squares in order to change it from parentheses squared minus something into parentheses something plus something multiplied by something minus something. Let's do an example of all this. So let's go back to step 1. Let's do an example of how to complete the square using this equation right here. So I'm going to complete the square for x squared minus 6x minus 14. Step 1, I'm going to change this into 3 terms that is a perfect square trinomial with either a plus or a minus and then a number. Okay, first thing I'm going to do is move my constant term over. I'm just leaving some space. I think we would all agree that these 2 lines are equal since They both have x squared, they both have minus 6x, they both have minus 14. So these two lines are equal. Every line here should be equal to every other line. Okay, so let's continue. Now, what I want to do is I want to have these three spaces right here be a perfect square trinomial. So let me first copy these two lines. Okay, obviously these two lines are right now equal to each other since it's the same thing. Now, I'm going to add here the number that will make this a perfect square trinomial. The number that will make this a perfect square trinomial, if your a is 1 and your b is negative 6, is we take our b, you divide it by 2, and then you square it. Now, this right here is a perfect square trinomial. I'm also going to subtract that exact same thing I just did. Okay, so these two lines right here are equal to each other. The reason they're equal is because this is equal to this is equal to this, negative 14 is equal to negative 14, and this part right here in the middle is just the number 0. So adding a 0 won't change the value of the line. So why did I do these two little pieces? I did these two little pieces, or I did this piece right here, in order to make these three terms here a perfect square trinomial. And I did this part right here in order to keep these two lines the same. All right, maybe all right here. This is now going to be a perfect square trinomial. Let's simplify this line. All right, negative 6 divide 2 is negative 3. Negative 3 squared, or negative 3 times negative 3 is 9. So this right here is plus 9. This is minus 9. We have minus 14. Okay, so now this part right here, these three are a perfect square trinomial, and I want it to be either plus or minus a number. So let's just combine these two numbers. All right, so there you have our step number 1. We now have a perfect square trinomial plus or minus a number. Perfect square trinomial minus a number. All right, next step, our step number 2. We're going to be changing that into parentheses squared minus a number using our perfect square trinomial theorem. Okay. I actually did mean to have this in blue, so let me change the color real quick. All right. These three terms right here is equal to x minus 3 squared. If you want to go from here to here, one way of doing it is the square root of x squared is x, and the square root of 9 is 3. This minus sign here is because this is a minus sign here. All right, so now we have that minus 23. So I've now changed it into parentheses squared minus something. So that's our step 2, going from here to here. Step number 3 in our step number 3, we're going to be using the difference of squares to change this into parentheses, something plus something, multiply something minus something. So, all right, using our difference of square theorem, what goes here is the square root of this first term. The square root of x minus 3 squared is just x minus 3. The square root of 23 is just square root 23. There is no simpler way to write that. That's it. Reminder, in the most technical sense, stopping right here, you would have done the completing the square. But I'm going to ask you to do this last extra step. So, all of these lines here, each one of the lines here are all equal to each other. This one's equal to this one. All I did was put some extra space. This one's equal to this one. This blue stuff right here is just the number 0. So these two right here are just equal to the number 0. So adding 0 will not change the value. I just simplified going from here to here. These 3 terms are exactly the same as this. All I did was factor them. And this obviously was simplified. Here I just used the difference of squares to go from here to here. But if you multiply this line right here, you will notice you get this. So all these lines are equal to each other.